Okay, today we get to add a variable to both sides of the equation and see what we can get. So starting here with 1a, it's going to work out the exact same, where if it's being added or subtracted, I'm going to add or subtract to get it to the other side. So I'm going to subtract 3w to move it to the right-hand side. And then you're just going to basically combine like terms is all this is. So 7 minus 3 is 4. So it would be 4w. Now how come I moved the 3 and not the 7? Well, the 7 was already kind of by itself. If I had moved the 7, that would have canceled everything from the right-hand side, and it would have been really difficult to work with from there. So try not to cancel everything out from one side or the other. Okay, 4 is connected to w. How do I get rid of it? Divide. Ooh, and it looks like I have a fraction answer. Yay! There you go. That's really all we're doing today. Let's go ahead and try a more complicated problem. Looks like here I have some distributive property I can do. So I'm going to take the 3 and distribute. 3 times 6 is 18. 3 times negative 2s is negative 6s. Now this time, since there's 2 terms on both sides, what I mean by that is there's 1, 2 on the left, 1, 2 on the right. I'm not as worried about which has to move to the other side, but sometimes I do like to move it specifically so that I won't have a negative number. So what I'm going to try now is maybe adding 6s. Because if I had subtracted 8s, that would have given me a bigger negative on the right-hand side, which is fine. I could have still solved it. It's just that we tend to have an easier time if we're not messing with negatives. So, all right, 8 plus 6 is 14 s's. Oh, and check it out. I love it when this happens. That cancels. Now it looks like I can add 10. That's going to be 28. And again, I get to cross that out. It's always a good feeling. And since 14 is connected to s using multiplication, I get to use division to make it cancel. And let's see, 28 divided by 14 is 2. There you go. That's all. Just use the distributive property. All right, I want to give you a couple special cases where things go funky. So first things first, I always start with distributing. So 5 times x is 5x, and 5 times negative 1 is negative 5. Don't forget I still had a 7x up here. Okay, now here's where people tend to make a mistake. If they're on the same side of the equal sign, you are just combining like terms. You don't have to add or subtract it to make it go away. You're just combining like terms. 7x plus 5x. Don't try and subtract one of those. They're on the same side of the equal sign, okay? So 7 plus 5 is 12x's. Minus 5 equals all this stuff over here. And let's see. Let's try and get our x's on the same side. So I'll subtract 12x from both sides. And 12 minus 12 cancels, and 12 minus 12 also cancels. Okay, so I'm left with negative 5 equals negative 5. Hold up a second. Negative 5 equals negative 5. When will that be true? Always. Negative 5 always equals negative 5. So in this situation, it doesn't matter what number I plug in for x, the equation will always hold true. So your answer here is going to be all reals. Okay? Now I know that's cumbersome to write out 100 times if you're doing a billion problems or so. In math, if you see this symbol, 2 lines inside the R, that means all reals, and that's your answer. Okay, that wasn't fun. We didn't have an actual answer. Let's try 3b. So I think I'm going to have to use the distributive property again. So 6 times y is 6y, And 6 times negative 5 is negative 30. And 2 times 10 is 20. And 2 times 3y is 6y. And now let's not combine like terms, simplify here. Since this 6y is on the opposite side as the other y, that is why I am subtracting it. And it looks like they cancel. And now I have negative 30 equals 20. Oh no, all my variables went away again. Okay, so this time I have negative 30 equals 20. When will negative 30 equal 20? Never. Negative 30 never equals 20. There's nothing in the entire world that you can plug in that will make this equation work. So in this case, the answer is no solution. All right, that is it for today.